any extra capability you want to add, that will be a very extra added advantage to you. Okay, so let me explain you guys what is dynamic provisioning. So guys, we have done one topic already, uh, where I explain you what is distributed uh, setup, where you have one Jenkins server that's called master, and we have multiple slaves, or it is also known as worker node, slave 1, slave 2, or worker node 3. Now guys, understand one thing. Okay, why we need this distributed setup? I already explained to you, and we also done this part. Okay, one of the main reason to have this distributed setup is maybe my client is come with a job. They provide this job to the master, and I ask the master, can you please help me to run this job? Now it is choice of the client or the user what they want to do in the job. This, so they write multiple steps. I want to first go to GitHub, download the code, then I want my code to be compiled, then I want my code to be create a package, or maybe they say my code is in the Java language. Okay, so I want my my code download from GitHub, and after download, this code compile, and after compile, this code create. We do some testing on the code that there's some means whatever functionality we need in this code, it will be it is working great, and maybe after this I want to create a package or software so we can use it. Okay, so maybe they give this kind of job to you. And because guys, I already explained you yesterday about this example. So whenever you have any Java code and you want somebody compile, somebody test, somebody create a package, so there's one famous tool in the market that will do all these three things for you. It's called Maven. I can ask Maven to compile, I can ask Maven to test, I can ask Maven to create a software called package. Okay, but Maven will do this thing for you, but your user or the client of Jenkins or Jenkins master or Jenkins server, they have to tell in the job what they requirement, what they want to do. That they obviously the Jenkins don't know. You have to tell those Jenkins with the help of job. So let's say this user say, this is my job, I want to do this thing, or maybe I want to run this read command, whatever your requirement is. Okay, but in this requirement, but it's what always, because the job say I want to use Maven. Okay, so two things we need. First of all, okay, because you are asking Jenkins that I want to use Maven. So Jenkins, do you know anything about Maven? Do you know how to run MVN command? Do you know how to ask MVN to compile? Okay, so typically Jenkins guys don't know anything about Maven, and that is the reason we have to extend the capability of Jenkins, and for this normally we have to use plugins. So we can install Maven plugin for Jenkins. But same thing, if I ask Jenkins, do you know how to download code from GitHub? Jenkins don't know. Again, with the help of Git plugin or GitHub plugin, Jenkins extend their capabilities of their feature and then use, and they know now how to go to GitHub and download the code. So this also we know already. Okay, but so it means in this setup we need two things. First, I need plugin in the Jenkins server or Jenkins master. Okay, second thing, I need Maven. Jenkins only know how to use Maven command. But if Maven is not there, Maven is a software, if Maven is not there, obviously Jenkins won't help you. Okay, for example, if GitHub is not there, so Jenkins know how to call to GitHub, but if GitHub is not there, so how Jenkins will help you? So Jenkins is only helping you to ask that tool like Maven or GitHub to do something for us, but the Jenkins never create those tools. Okay, so it means the one more requirement we have is we need Maven. Okay, and for Maven, it's free software, you can download, and after download, you can install. Now here the point is where you can install Maven. Either you can install Maven in the master node, for example, is IP1, or either you can install Maven in IP1, IP100, IP1. Okay, good practice say, okay, this system is a VM, virtual machine or the OS instance, okay, don't not try to install any of the software here, because if you install Maven here, it means Jenkins will call the Maven in the same computer, and if you Maven run the same computer, so this system, computer RAM, CPU, network performance they consume, or their resources they consume. So you want unwanted impact to your master performance. Okay, so always try to separate your job in the other computer that is typically worker node, and that is the reason it is not a worker node or the slave node. Master only keep for Jenkins or to manage Jenkins things like Jenkins plugins, Jenkins jobs, and something that is related to Jenkins. But anything that where you Jenkins want to integrate as a third tool, maybe Maven, maybe Docker, maybe Kubernetes, maybe OpenShift, maybe maybe Selenium, right? Anything. Try to put those things in the worker node. So guys, this concept I already explained you already in my distributed cluster part. Okay, but I just want to again refer you due to some reason. So technically, slave is meant for having tool like Maven. Okay, so let's say our plan is in IP1 we have installed Maven. Same thing, let's say in IP2, we have a virtual machines of Selenium, we install Selenium here. It's some testing tool or framework. Or let's say in IP3, maybe a lot of guys know Kubernetes. I need Kubernetes, so I install Kubernetes here, or maybe I have created some Kubernetes cluster somewhere. So multiple node, worker node, VM we have, and every system has come with their own tool install. Now what happened when the job come, and and you guys know I showed you this spectacle already. When job come, my users say this job need Maven. So in the job, the tag that I need Maven means they set the label that I need those node that has some name or IP that has the Maven. So finally, when the job come to master, master will run the job only in this node. So this is called distributed cluster. Till here, guys, we had already discussed, again, quick revision for you of multiple topic, plugins, Maven, and distributed cluster as a quick revision. Now, from here, our main topic start, and main topic for today is dynamic provision. So what is this topic all about? Okay, so in this setup, guys, now if you try to think, okay, how many worker node we're going to need? Okay, so typically, guys, Jenkins is a tool that we can integrate with anything. We can integrate Ansible, Puppet, SAF, hundreds of things we can integrate, and thousands of things we can integrate Jenkins with. And almost in all the industry environment, okay, they have a job, and almost all those jobs require Maven, Kubernetes, Ansible, multiple different set of tools they require. One job or maybe hundreds of job of 100 team, they are using maybe same Jenkins, and everybody has a different tool required like Maven. Okay, but having this tool, okay, we need we need slave system or slave system virtual machine. And if you have virtual machine, you have to put CPU, RAM, a lot of hardware resources you have to give. Okay, and these resources they have to keep on running, because if this OS is not running or IP1 is not running, and when the job come, obviously job won't be able to provide to this guy, and obviously finally my job failed. So to keep running the system continuously, forever maybe. But there might be chances, maybe today no job come up, maybe tomorrow no job come up, maybe tomorrow, day after tomorrow, only two job come up. So it is unwanted wasting your physical resources, your electricity and other things also. And it's not like only one Maven I need. Okay, it's good practice normally for security reason also. Maybe other team also come up with a different job. They also need Maven. But they say, I need Maven, but I don't want my job to be run in the same system where other job run. Because I have some critical code, it might compromise. So give me different system, different VM, different hardware resources. Okay, let's say slave 3 or slave 4, where again I need Maven. Okay, so again, guys, if you try to see here, hundreds and thousands of worker node we have to provide, and main thing here is it is a huge wastage of the resources, because we are not keep on using these resources continuously. If you're using this, okay, but we're not using here, it's a pure wasting of money and the cost and the resources. Okay, and this is also a very common thing, mostly. Okay, if we run the job if you run the job of some user, they come here, let's say the job run on IP1. After job run, then there's no use. There's no, the job is done, right? They done their duty. Okay, and after this, there's no as such data we put in the slave node again, job to job. Okay, where my team need. Okay, so technically, what I'm talking about, after the job run, my team might not require the same node. Okay, so we can delete this node. So what I'm talking about is in some further example, I will a little bit elaborate this topic. What I'm trying to explain here is, but let's come back to the older discussion here. So finally, what I'm trying to explain you here is, okay, there's a huge wastage of the resources. Just stick with this point or stick with this challenge. Okay, so what can we do to solve the challenges? Let's do one thing. Okay, right now we launch all this worker node. Okay, like a like a static kind of thing. Okay, we launch this all the node statically, means fixed, means we just launch it, right? Before, as soon as we launch the cluster, and just waiting for when the job come up. Okay, so again, this static means it is unwanted when wasting our resources. Okay, so let's do some intelligence here. Means let's do one setup in such a way, don't launch any of the worker node or don't launch any of the slave node. Guys, by chance, if you launch any system with some setup, this launching is also known as provisioning. Okay, so don't do static provisioning. That's what I'm talking about. If you don't any of the worker node, if you don't have, it means there's no wasting of the resources. But do you need worker node? Yes, according to this example, I need worker node. But initially, don't go for worker node. Let's have only single master running. Okay, and let's do in this way. Let's wait for the job. And guys, this time what we are doing, as soon as the job come, they go to master, and master see this job looking for Maven. I don't want to run my Maven in this system the way I showed yesterday or my last class. I don't want to run my Maven in my master node, but I need worker node. I don't have a worker node. Okay, so what master will do, master will first go and launch a new virtual machine. This entire setup master will launch, right, as when the demand come. It's also known as, guys, on demand basis. So as the demand come, then they launch the virtual machine. After they launch the virtual machine, they install the Maven. After they launch the Maven, they do all the configuration of Maven, and then they submit this job here. They run the job. Okay. After job run, they provide the result to the customer, to the user or the client, and then they finally remove this virtual machine. Okay, because obviously we have to save, because job done, so there's no meaning to keep on running this virtual machine. Okay, and just remove it, and after virtual machine remove, obviously my hardware resources will free. That's what our requirement is here. Okay, so technically this concept is known as on demand, or maybe we can say we are launching a virtual machine or our environment. How? Dynamically. But here the bigger challenge here is this setup is good. Finally, this setup is is helping you in managing the resources. That's what one of the key for the industry. Okay, but this challenge has one issue. Okay, this challenge is this process has one issue. The issue is this process is very slow. Let's say one job come up and this job is very critical, and this job is doing some software testing, and this software testing has updated some software code that is based on some very critical security, and they want to very quickly test the software, build the software so that they can patch their actual production system. And if this job will submit the master, and master say, I will run your job, but you have to wait. Okay, I don't want to run I want to run the job, but you have to wait. And master say, just keep on waiting. Keep on waiting, because what I'm doing behind the scene, I'm provisioning your resources, provisioning the worker node. And because this is a virtual machine, so installing the virtual machine takes a lot of time. Then downloading Maven, then configuring Maven again take a lot of time. Maybe 20-30 minutes it's going to consume. After the system launch, again it's dynamic provisioning only, but after system launch, then I get your job, I will assign this job, to this OS, what I will launch for you on the fly. I run the job and give the output. So again, it is this concept is dynamic provisioning, but in this concept, the challenge is setting up this environment take a lot of time. Okay, and here the guys role of container technology come in play. Okay, container technology, one of product of container that you guys know, Docker. So guys, if you go through my Docker classes, and this is one of the concepts I explain in my Docker classes, the great thing about the Docker is if you want to launch any OS or any environment, when I say environment means you want one OS on the top of you need some product, some software. In my case is Maven, and you want Maven to be set up. So this is called entire OS or entire environment. So if you want to launch entire environment, right? Entire environment you can launch or provision just within a second. So that's just so quick, very fast. And that's what we need, guys, in the today's agile world, fast world, right? We can't wait for 30 minutes to have one worker node to launch. Or maybe after this, my job failed. Again, I change my code. Again, same thing happened dynamically. So I don't want to waste so much time. Because testing is this thing, or running the code, building the code, we have to run hundreds of time, maybe in an hour or maybe in a day. Okay, so I want a quick solution. First of all, I have to save my money in resources, so I don't want to go for static provisioning, but I need cluster so that whenever resources need, then only my resource launch means my OS. But I don't want to waste my time also. I want to improve my time also there. So there, the role of container technology come in play. So now it is your choice. You want to use Cryo, Podman, Rocket, Docker. So multiple container technology now or container engine we have in the market. Right now today, I'm showing you the practical with Docker. Okay, because Docker is simple. Everybody know this. So let's do the practical with the Docker. So like this is the today's plan. So finally, our setup would be something like this. Something like this. Okay, very beautiful setup. Exactly same demo that I did yesterday. I'm going to show you. So I'm going to write a job. My job will submit to master. A master C. This job is looking for Maven. Okay, so master C, I don't want to run on my system. So I will launch a worker node for this job. Okay, but how fast I launch is depend. So because I'm going to launch this job with the help of Docker, so within a second, this OS launch or this container launch. So guys, either it's a word container, environment, OS synced. Or as soon as the container launch, and you guys know one more thing, because this is a worker node, and you guys know whenever worker node, slave node launch, you have to first connect the container to the master, or you have to connect the worker node to the master. And if you guys remember, whenever we launch a worker node, we have to put a Java agent here or Jenkins agent here. This is the one who will connect. So this part is also to automated. So as soon as my master launch this container has the OS. This container has a pre-built Maven setup or whatever different tool you need they have, and plus they have agent also included. So as soon as the container launch, Maven come up, OS come up, plus agent start running, and as soon as agent run, automatically connect to the master. So technically, as soon as job come within a second, your container also launch, environment launch, and one slave on the fly dynamically connected to the master. Okay. As soon as master get the agent, now the job is ready to assign. So this job master assign to the same guy because this is the one master launch. And inside this OS or the container, they run entire job. And after job runs successfully, we provide the output to the client, and then they launch or they destruct the setup. Because removing the setup in the Docker again within a second. Within a second, we'll remove it. So guys, it's like, very interesting. If 1,000 job come up, suddenly 1,000 different container or different slave worker node started their work. They are running in their world. They do the task for you. whatever the job completed, they will terminate on the fly. Very, very much beautiful setup it is. Okay. This is one thing. One more small thing that you guys might know. In the Docker, if you want to launch the OS, that is equals to container. Okay, you need a image, and from the image we can launch the container. This is called Docker image. Very basic thing. So what this OS contain? The OS contain what are things that is available in the image. Okay, so in my case, what I need, so I need I need OS, I need Maven, or I need Java Jenkins agent. Why agent? Because this OS, after the launch, right, my worker node has to connect to the master or to register the master. So the master will assign the job. So three things I need. So if you want these three things in the in the container, so all these three things you have to put inside the image. Okay, how? So anybody who know how to create Docker image with Docker file, okay, so you can create Docker file, and you guys know by chance how to install Maven. Yesterday I told you how to run the agent, how to install the JDK, all the steps that I already discussed you guys in my slave part manually. Same thing, you can put a Docker file, and from the Docker file you can get an image, and your image is ready. So this class is not about the Docker class. Okay, so I don't want to show you the spectacle here, but creating your own image is not big deal. So this image I already have in my Docker hub, so I'm going to use that image. If you want to use that image also, you can use that if your choice. So if I go to hub.docker.com, so I have my own account, and in my account, his name is Vimal13. Okay, in this account, I have an image. Okay, it's called Jenkins slave Maven image. Okay, so this image I have created, and this image contain what? Okay, this image contain your base OS, Maven install setup, agent of your Jenkins, and Java JDK software. So everything I put in one box. So either you create by yourself, if you know the Jenkins, or you can use my image. So I'm going to use this image today. Okay, this one thing. So let's go, guys. Do our demo. So let's go into the demo. So in my case, this system is gonna work as a Jenkins master. Okay, so guys, our practical will be something like this. Okay, so I'm going to use two different machines. One machine will work as a Jenkins master. Okay, and one more machine, guys, I am going to use. Okay, one more machine. This is my Red Hat version 8, but this machine I'm not using to create a slave. This machine I'm using for one purpose, to run a Docker. So my Docker server, also known as Docker engine, is running over here. So now it is your choice. You want to run your Docker engine, your Red Hat 8 or Windows or Mac in your local machine, or in the AWS cloud, or maybe in the Docker cluster. That will be your choice. Okay, so I'm using this another system, not for worker node, only for running Docker engine. So this second system I have where I have already installed Docker and running Docker engine. So this is the only thing. Okay, so what I'm going to do, okay, understand one thing, guys. If you want to use Docker, you need Docker engine. Okay, and Docker engine is in the system. So what I'm going to do here, I'll tell my Jenkins that you don't have any pre-set up static slave. But when a job come up, try to run the job only in slave. Okay, but here you go for dynamic provisioning. And for the dynamic provisioning, okay, ask your master. Master will contact to Docker server and ask Docker server to launch new container. So technically, you tell the master where your Docker engine is running. So in my case, my Docker engine is running here. So master will go to Docker engine and say, I would like to launch a new OS. And guys, guys, in the Docker engine is known as container. One container, 10 container, hundreds of container. You can launch on the top of Docker engine. Means 100 OS you can launch. So master will go to Docker engine and ask, I want to launch a container. And because right now master will ask to launch a container from this image, from this image. Okay, so the beauty of this image is as soon as the image launch, automatic agent run, and as soon as the agent run, this container automatically register with the master. So master will see one new slave node come up. This also register, one more new come up. This also register, depending how much master need. So 2 or 3 hundreds of new node or slave node master come up. So understand one thing. Okay, now my cluster has one master, and how many slave they have? This is one of the slave, this is one of the slave, and this is one of the slave, and more slave we have. Okay, so and this slave is a dynamic. We launch, we run some job, we run some program, and then terminate. So it's called dynamically. So when new job come up, then master asks the Docker engine to launch. After job done, they will terminate. So this container will work exactly like your slave node. The setup that I show you in my last classes, exactly like it will work. Okay, so let me show you guys this demo. Okay, but understand one thing: Jenkins master will connect to my Red system. that Docker engine running. So let me guys show you this demo. And one more thing I'm doing here, because a lot of practical I have to do. So let me create a document and put everything there. Okay. So the Jenkins class. 1 minute. Where Jenkins. Okay. So let me show you guys step by step how we can do. So in my case, this system is the system where sorry. So this system is a system having the IP address 145. I think this is a system where my Jenkins master is running 5. Okay, and this other system where my Docker is running. I already guys installed the Docker. Pretty simple. Install the Docker and start the Docker. So I can show you system.ctl status Docker. So in this case, my Docker is running, no challenge. Okay, this part is done. So an IP of this system is 1.3. So IP3 of my Reddit 8 is where Docker is running. Okay, now so this setup is done. So how to implement, guys, this setup? What actually I explained to you. First of all, guys, you have to tell the Jenkins, okay, that you have to communicate with the Docker. And I told you guys, Jenkins don't know by default how to connect to Maven and how to connect to GitHub. If you want Jenkins will do something for you, you have to use plugin. And there one more plugin, guys, is available in the Jenkins called Dockers. So if you give this plugin to Jenkins, then Jenkins say, now I know how to communicate with Docker. Okay, so that's what we have to do first. So I have to go to my Jenkins running in IP5. Okay, and here I will tell my Jenkins that you have to connect or integrate with one more technology or tool that you don't know by default. So I am installing a plugin for you. So you guys know, go to manage Jenkins. And here we have option called plugins. And here you go to available and search for Docker. So you can guys see one Docker plugin come up, but I don't have here because to save to save your time, I have already installed this plugin. So in my case, it is there in my installed. Okay, so if you go down, so you can see guys, there's one Docker plugin you have to use. Guys, there's a lot of plugins because Docker is famous tool plugin available for Docker, but you have to install a plugin with the name called Docker plugin that will integrate Jenkins with Docker. So just keep this in mind, install this particular plugin. Search this plugin, click install. So nothing fancy here, but obviously when you install, it will download from the net. It takes some time. After download, restart your Jenkins, and after restart, this plugin start working for you. So for Jenkins side, this is the only thing you have to do. So technically, if I ask my Jenkins, do you know how to uh, connect to Docker? Answer yes. They say I know how to connect to Docker. Okay, so Jenkins part is done. We install Docker plugins. Okay, now in Reddit, in other system, we need Docker engine. Answer, do you have? Answer, yes, we have. But point guys here is, right, how Jenkins can connect to Docker. What I mean by this? It's a very basic thing. Very basic thing. If you have two different computer, there's IP1 and IP2, and there's one program running in IP2, and if there's one program running IP1 and this program want to connect to IP2 program, how they connect? Obviously, we need network that we have already. We have IP also. There's one thing we need. But one more thing we need, guys, if this program doesn't support that anybody come from network and they can connect. Guys, normally in the network, we come normally with TCP UDP protocol. So this program say nobody can connect from outside using network protocols. Okay, but if you want this program have a capability to connect that anybody can connect from outside world using network, then this program should support TCP or maybe UDP. If you enable UDP TCP, then every program they will provide a port number. Okay, so this is a very common thing. So technically, in our case, this program is Jenkins, and this program is Docker. And guys, by default, Docker program don't have a capability that anybody from outside world can connect. Okay, I'm not talking about guys Docker container. Docker container is just a different OS. You can connect. I'm talking about Docker engine. So Docker engine don't have a capability that anybody can manage Docker engine from outside. Only way to manage Docker engine locally. Okay, so if I talk about here, if I run and see this Docker engine, okay, this Docker engine on which we going to launch a container, it only controlled locally. Why? Because it is written inside the Docker engine, or can say Docker service, or also known as Docker daemon, that your Docker engine is only running with FD. This means called local. So guys, this one concept called Unix socket means technically in the simple term local. So this guy doesn't support networking. So I can control this Docker engine manually. I can run Docker PS command is running. This basic command, Docker images command is running. It's showing all the images that I have locally in my system. Okay, so my PS command I have an A. All the container that I launched till date I don't have. It's new clean system. Okay, so technically this command is doing what? So by this command, I am managing Docker engine. But right now my Docker engine and this command both is in the same system. So they have a local control. This is called Unix socket or local sockets. Okay, but my Docker engine don't have a capability that anybody can connect from outside world. But I need here. Because normally Jenkins run somewhere else and Docker run engine or Docker setup running somewhere else. So for this guys, you have to enable this support. The Docker engine, you should support TCP connectivity. Okay, and for this, I have to tell my Docker services, Docker daemon, okay, you have a local support, that's okay. I want to add one more support. And for this, you have to go to some internal file of Docker. And guys, when you run the status command, this is the file they're talking about. So you go to this file and where you can go and add. Okay, so I go to this file. Okay, and here in the line execute start, after this line you can add one more edge option and say now you have to support TCP. Anybody come to you to your IP address, and what is your IP address? I know by chance. Okay, to a port number. Whatever port number is free right now, you can do it 1111, will be your choice. But typically, Docker normally work on port number 2376. You can give any port number, but this is a typical port we always give to Docker. Okay, so if anybody come to your system and your IP is this one, to this port via TCP protocol only. Okay, then from outside they can control you. And by saying this concept is called socket binding. So anybody who knows sockets, or maybe in my Python program, I discuss anybody who attend this program. So that's what we are doing. So that's the only thing, guys, you have to do. Or because we change something in the internal file, and guys, this is the systemd file, because your Reddit system is purely controlled by systemd, and all the program is controlled by systemd. So any file that you change in the systemd, you have to reload their database, and the command is called daemon reload. Okay. So this I run to update systemd program that something changed in your internal file. Or because I changed something in Docker, so I have to restart my Docker service also. That's all. So this is, guys, only thing you have to do. And now if you again run the status command, what you will see now, my Docker engine has a capability to control, manage locally also with Docker command, and somebody from outside world by using Docker command or some other tool like Jenkins, they can also come to my system on my IP and my port number, and they can control. That's what we have done. So technically, this is the only thing you have to do over here. Okay. So Jenkins part we have done, Docker engine part we have done, and finally we have to do a connectivity. Okay, and connectivity means, okay, I'll tell my Jenkins master that now you have to manage your node. And how to manage the node? You know this tab we have already seen. You have to manage your node. Now how to manage? Add a new node. Okay, if you add a new node, this packet I show you how to add Linux's node or Windows node. But if you do so, then this is called permanent node. Means fixed node. But I don't want fixed node or permanent node, it's called static node. But here what I want dynamic provision. So I don't want to go for this setup. Okay, let me again go back. Okay, I want when the need come up, demand come up on demand, then my node automatically start. That's what I want. Okay, so in this case, what to tell to the master? Okay, I want you go somewhere, and there's somewhere maybe Docker, maybe Swarm, maybe Kubernetes, maybe AWS Cloud, Azure Cloud, wherever, maybe OpenStack, wherever you want to go there. Okay, and when the need come, then ask them to launch the instances, launch the VMs, or launch the container, whatever technology they support. So for the Jenkins perspective, these guys are known as cloud. Okay, and that's why is the option here in the node part. There's an option called configure cloud option. Come here. Click configure. Okay, right now I don't have any cloud. Okay, and there's one thing, Docker is not cloud, but for the Jenkins perspective, they feel it is a cloud running somewhere else. Okay, and here they're asking you to add a new cloud. And by the way, guys, this name already here. Okay, why is here? Because we have installed Docker plugins. And when you install Docker plugin, this name automatically comes up. Okay, you just click Docker. And when you click Docker, this page come up, and here they're asking two things: Docker cloud details and agent templates. Okay, what they have. So obviously, guys, logically, what to tell to the Jenkins masters, we have to tell when any job come up, and if this job is looking for, let's say, to set up to run Maven, just for example, or date command or any command, right? So first of all, you will go to IP3, contact to Docker engine, ask them to launch container. Maybe so Jenkins should know where Docker engine, right? And for this, you write cloud details. And you deploy a URL, means identify, means URL. And in our case, guys, I'm in 5, and where is my Docker running? In IP3. So I type here 192.168.1.3. This is the IP, and there are multiple programs running. One of the program is called this one, and this is the port number of the Docker that I configured there. And here my Docker is running. Okay, and which protocol they support? They support TCP protocol. Okay, so that's the only thing you have to do right now, guys. This connection is very open. I haven't said any authentication part here. So for the obviously for public world, it's not safe for outside world or anybody can connect. This is my local private laptop. Nobody can connect. So I'm not setting any authentication part in the Docker side. Okay, if you have, you can set from here. So let me test my connectivity. Is a button here, test connection, and the connecting. If there is some issue in anything, they fail. But in one single go, guys, they work. Even though they detected that I seen that you are running Docker 18.49 version. So guys, this is actual version of my Docker. Even though I can very quickly check. Okay, with the run of Docker version command, you can see this is the exact version of my Docker engine run. Okay, my server running. Okay, so they detected means fine. But in your case, guys, if fail, if you do all the setup, there might be one reason in your Docker engine you have firewall and firewall is blocking. Okay, so right now either you create the rule or maybe you can run the stop firewall command. So this might be reason it might fail in your case. Stop the firewall or maybe make it for permanent disable. Okay, so you can also try this thing, then it should work. So this part is done. Okay, and we want to enable this, click, so it will work for you. So just go and don't forget to enable. So just go and enable this part. Okay, so this part is done. Now one more thing, guys, we have to update here. Docker is there. Now we have to tell my Jenkins. Whenever this job come, okay, and let's say this job is need Maven. So then you have to go to Docker engine, ask to launch a new slave, new container. A container, guys, is always based upon image. Okay, so you launch a container from which image? Okay, obviously you have to tell, right? You want to create with MySQL image or HTTP image or which image, right? So in my case, I want to use an image that contain what? What we need. I need base OS plus Maven plus agent, and this image I already have where by chance in my in my Docker. So this image I need. Okay. This particular image. So how to tell to Jenkins? So here the role of Docker agent template come in play. Means at the agent side, I mean slave side, you're going to launch image. That image should contain agent or plus extra thing, whatever you need there. In my case, let's say Maven. Okay. So put here the image name. So click here. Okay. And here they ask you to add a Docker template. And here, guys, they're asking you which image you need. Okay. So this particular image, guys, they use for what? To launching the container. After container launch, this container work like your slave or worker node. And this worker node will connect to the master. And guys, that's one thing, guys, whenever you launch a worker node, when I go with static, we have to give our worker node a name, node 1, node 2. But here, guys, they give you a random name, but obviously they want some prefix to add. So this is what the name is. So let's say this is my node Maven. So they add this prefix and some random number so that if they launch 100, so name won't conflict. So this will be your node name. Okay, for the Jenkins perspective, and they launch a container from this image, and this container will become slave, and the slave name for the Jenkins perspective this one. Okay, one more thing, guys, I explain you in my in my slave side. Whenever run the job, we always assign the job to slave. And normally we don't know the slave IPs and slave name. Normally we understand the slave with their unique tag. That's called label. So it's good practice, guys, to add the level. And I know this image have a Maven, so I can say this is my slave Maven. So add some tag so that while creating the job, we assign the job that I don't know the node name, because here the node name they give me this one plus some random number. I don't know the node name. What a name come up, what a IP come up. So every time container will give a different IP. But I know the label. So any node who has this label, connect or assign the job. Okay, it's like this. So this is a way your master will assign the job to the dynamic provision OS. Okay. So that's what, guys, I have given you. So there's the only setup we have to do. And let me show you with demo it is working or not. Okay, anything else? Obviously you have to enable this. Don't forget to enable. Okay. And there is some extra setting about the container, other things. As such, we don't do any changes here. Okay. So as such, I don't think so any change. We can add more templates, multiple images, but let me save. So this part has been saved. Go here. This part has been configured. Okay. So technically, finally, the conclusion is this one. You have one single node running. If you click here, only master. And by the way, I told you master has only two executor. It normally good practice don't provide any executor master because I don't want to run any job in the master, but that's okay. Keep on running. There's no challenge. Okay, but there's no, if you see, guys, there's no node here. Okay, and now what I want to show you guys here is, let me open my new page here. And what I'm going to show you here is, I'm going to create a new job. Let's say this is the dynamic job one, freestyle. Okay, let me create a new job. Okay, and in this job, nothing special here. I'm just creating a job to run just a date command. Okay, but date command will run very quickly. So let me run sleep command also so that my job will hold for 30 seconds. Okay, so I can see what is going on. Okay, but I also want to do one more thing. If I save this, when I run the job, by default this job will run in my master node. So what I can do, I will say that I want to restrict this project where in the level called my slave Maven. And guys, this interesting thing is here is, by chance this slave is not actually exist, even though we are attaching the level. Okay, what I mean by this, the meaning of this is okay, we're asking the master when we run this job. Okay, I want to run the job only in this slave. If this slave is static, if not they're running, my job will always wait. But by chance this slave is dynamic slave, so I'm asking the master, go to this slave. Okay, first launch this slave for me, and what do we want to do further? After launch, you register the slave with you, and after your process done, then put my job there. Put my job there. Okay, that's the beautiful thing, guys. They will do for you everything dynamically or automatically for you. So pretty simple job. Okay, and understand one thing. In my dashboard, in this page, guys, you see I don't have any node, but dynamically new node will create. Okay, this is one thing I want to show you here. One more dashboard, let me open. Here in my dashboard, you will see I have only two executor from master. So guys, as soon as new node come, automatic new node name updated here, and new node will come by one executor, one name automatic come for you. Everything dynamically. And after my job completed, it's good practice. Follow here. they will terminate the node. So my node will remove from here, my node will remove from here. So they keep on exist till the time my job run. So that's what they follow here. Okay, this one thing. And one more thing, guys, because finally everything gonna happen in my Docker engine. So what you will see, your job finally gonna run in your Docker engine. Means technically, as a Docker perspective, they will run not this system. As a Docker perspective, they will run new container. Right now, guys, there is no new container over here. Neither running, neither stopped. Everything's clean. So you see, guys, my Jenkins will come to the system and run the container on the fly. So everything, guys, you see, you don't have to worry. But I want to show you that everything is running automatically. Okay. So let me build the job. And what you see here, when build, you see this might be first time you see your job started, but they're waiting. And why they're waiting? Because they're asking the master to dynamic provisioning the slave. So let me start from here. Slave. And now see, guys, your Jenkins is waiting because this one is not available. And by chance, behind the scene, if you go here, okay, you can see one node. Let me refresh the status. One new node automatic come up and they are cross because behind the scene, guys, this node they are launching. After launch, they connect. So this node connected. If you see here, the status of this log is my is created log of where I have the particular log, some logs. They see as in connected online on the fly. And if you go to my doing a little faster, you can see in the main page one more idle come up, and this is then this node. Okay, and very quickly if I go to my Docker, one new content launch from the image, whatever image provided. Okay, so my job is running. My job is successful. After job successful, they terminate everything. Okay, it means if I again go to my my node, okay, this node they removed. It's like there's no node available, right? They removed it from here, and they remove from here, and also they also contact to Docker and say now we don't need any container. See here, they remove the container. If you see PS also, they remove permanent. We don't need this, right? So they remove it because my job is done. My job is done. So everything done. And if I ask the job where you run, they say I have assigned to a node this one in my remote system. So and this is the output because somebody asking me to run the output there. I run the output and I'm successful. So very beautiful practical, guys. Everything is automated. Finally, because we are running the dynamic provisioning, so we are saving a lot of resources. This is one great thing. And because this dynamic, I want things to be faster, so we used container Docker. So one click within a second, my node launch and my setup done. So everything we achieve by this setup. And also, guys, they show you in the log, they are built on the top of Docker. So they talk about where the Docker running. So they will tell you something about the Docker also. Where this job run. Okay, this one practical. So let me do one more practical very quickly. Okay, over here I'm configuring the same job. And right now what I'm doing, guys, I'm doing the same practical what I did yesterday. I go to my GitHub. Okay, and I'm searching for Maven. This is the app I used yesterday. Let me clone. Okay, if you want, I'm just sharing this URL to you also. Okay, and now what I'm doing, I'm creating a job. Already opened somewhere. Yeah, I'm doing the same practical. So I'm asking my job to download this code. Okay, after download this code, this is Maven. I don't want to run any commands. I want to first run the Maven test, for example. Run the Maven test that I showed you yesterday. In the code, run the Maven test. Okay, and after test, I want to do one more thing, Maven package. Maven package. After code test, just create a package for me, means create a jar for me. Okay, so let's guys run this job. And now what I want to tell you here is, okay, Jenkins know how to contact to Maven, but Maven require. But good thing is, guys, the image that I provided to you in this image is the one who launched the OS or container, and in this image, by chance, we have Maven set up. So technically, that's what I want. So in my slave system, Maven is there. So Jenkins will call to Maven and ask to compile or package the code. Okay, so that's my image. But if you don't want to use Maven, you want to use some other tool or other software. So your software contain those tools and the commands. Maybe anybody who want to use machine learning, deep learning. So in this image, you should have machine learning, deep learning libraries. Okay. So guys, in my Earth classes, I show you recently how to create an image that contain deep learning TensorFlow Keras library. So same image you can use here. Okay. So something like this. So okay, one thing, and one more thing I just want to tell you here is very important to know. Okay, whenever you run the job, right now my job is not running in the master, my job is running in the slave. And mostly job need some data, create some data. Okay, and guys, this data always store where the job is running. Because my job is running a slave, so what a code we download from the GitHub is stored in my slave. After my code compile and create a package, my package is also stored in the slave. Okay, so which means in this job, your workspace contain no data because my job is not yet started. But when my job is started, my slave is started, and the slave will provide their storage. And in the storage, they keep the GitHub code and they put my package and whatever data they have for that create. Okay, and that time you will see your data will come up. That's part you know. But the point challenge here is because this is the dynamic provisioning. After my job run, this entire setup terminate, complete terminate. It means what a code to download is removed. So that's okay because my code is there in the GitHub, so we don't have worry about this. Okay, but why we launch this setup? I need a final package, my software. If this entire setup remove, my package also remove. So there's no need of running this job, right? So how we tackle this problem? Let me show you in a minute how to tackle this problem. But right now, what I'm showing you here, let me run this job first. Build. And guys, dynamically your node starts here. They are looking for the node. And if you go here, again, they launch a new node. After node launch, my job start. You see, automatic job will start here after node launch and connect to the master. And in this time, my node, I asked, okay, my node is being run on remote node. Okay, and they create a workspace in the node only. They download GitHub, and guys, here they start Maven. This is the same thing we have done yesterday. Okay, and by chance they fail. One part they fail. Maven 2 times. Oh, because I write the go wrong thing, guys. Because obviously in your project we already have Maven plugin, right? And Maven plugin, guys, need only your goal, right? Maven command behind the scene they call, right? They need your goal. So just give your goal name. Okay. Because Jenkins know how to call Maven, so they automatically add Maven command for you. Okay. So let me save again and build. And guys, I can see here the thing fail. They entirely remove your nodes, again launching the new node for you. And because the Docker is so fast, within some second, your node launched, they are connecting, and my job start freshly. Okay, they connect here. And in this node, they're using their space. So now if I go to a project, you will see workspace create. And this worker contain all data that we download from GitHub. Okay. Plus, after my build, job build, all the data they keep here. my compile file, my my what do you say, my packages, everything they keep here. But the challenge is, guys, this workspace from this node, and this is a dynamic node. After my job completed, entire data will be removed because my node removed. It means your final package also removed. Let me show you. So let this process done. So Maven running, guys, and Maven guys always download in your new OS. They download your packages from the Maven Central, right? And then then they start compiling. Okay, so it might take some minute. Okay, and by the meantime, if I again go to my workspace, they might add some more data. Okay, say guys, target come up. Here we have all the report, my classes file. I show you guys this thing already yesterday. But everything, guys, this space not coming from master. Master showing you, but this space is coming from this slave. Okay, but challenge, you will see my job will definitely run successful in this node, and the guy, this node is running with a with a Docker container here. So everything running inside this container. See here, about a minute, and after this, if you go inside, it will terminate. Or maybe in the, if you know the Docker logs command, you can go inside this container to see whatever they have, log or logs command. Sorry, the container name, I think is removed. Oh, actually they removed actually. So actually my job is done, I believe is done. And they removed. Okay, so there's reason I can't go there. But what I want to show you here, if I again go to my job runs successful. There's no challenge come up. And if you see in the last, finally they say it's successful. We create a jar and put in the workspace. And by then, Buzzfin guys always come from slave, and the slave is dynamic. So it means if I go to my workspace, everything is removed. Means my final need, what I want, a jar file is removed. So in the dynamic world, the biggest challenge you guys might face, and how to tackle this problem is so simple. I already explained yesterday. Because your final need is your jar file. So after I can say, after my package create, after my build done, I want to do some post build action. And one of the post build action I can do is archive my artifact. That's what I need, right? Because my final need is what? I need my artifact, means my jar file. And I know my jar file is, is always there in the target folder. I normally know the file name, but I can use star.jar. So I'm asking you in my workspace where you create in your slave, go to target folder, retrieve all the jar file, and create an archive. Guys, archive guys always create in your master node. So technically behind the scene, this jar file they copy from the slave node wherever they are and put in your master node. And master node is always permanent. So guys, this concept I already show you yesterday, but now today you will see the actual uses, practical uses of this concept of creating the archive. Okay, save, and let me again build. And now you see my job run dynamically. They run on the slave node, they built on the slave node, and because my final requirement is to having the artifact, my jar file, after my build run or before job complete, they will download from the slave node and archive in the master node. And you guys know here they show the link, from here I can download. Okay, so this is the beautiful, guys, this is a very powerful setup. Now it is your choice where you want to create your Docker engine. Right now I created my Docker engine in my local laptop in one of the mushroom machine. Same Docker engine you can create locally also in Jenkins also, or maybe you can create a Docker engine in AWS cloud. So highly recommend, guys, those who know AWS, go launch EC2 instance there, set up the Docker engine. Okay, and ask your Jenkins, okay, that that the IP of this instance called public IP, that my Docker engine is running. So when you run your job Jenkins locally in your center, in your local laptop, they will contact to AWS, contact issued instance, contact Docker engine, and launch the container on the cloud. Run the job, and whatever final output you want to take here, they will download and put in the Jenkins. Okay, so that's what also you can do. Okay, so my job is still running, and a minute after they run, you will see artifact come up here. Okay, so that's all, guys. I think you really appreciate this spectacle, very powerful, actually very much useful. And the top of this, we can build now. We can add lots of things in the future. But this is setup that distributed dynamic cluster setup they have done for us. Okay, so that's all for today. In a minute after the job launch, I refresh and you can see artifact will come up. So any question, guys, it is done. Job completed successful. If I refresh, you can see, guys, now I'm the master and this jar come up. Even though I don't have workspace, but jar come up. If I click, I can download also. I can use also. Okay. So that's what our post build action means. So that's all. Any question, guys, if you have, okay, you can guys ask me. So actually, workspace actually Nikhil nothing. Workspace is just a space. Uh, um, workspace is just a storage, like a folder. So it won't create. Create means they provide some folder to you. Okay. Yes, Sobit, you can create your own plugins also. You can create your own plugins also. No, Ankit, actually, there is no use of Maven deploy because uh, Maven deploy means you want to deploy your WAR file or jar file. Here in this particular, I haven't used any deploy. Okay, I just want to create and copy here. That's all. So by saying the practical, I haven't used any deployment. But yeah, if you have package and you want to deploy file in Tomcat, I will show you some practical like this. There I will use a deploy command. Okay, deploy means put the archive in app server. So I don't need. I haven't used today, so there is no use of deploy command. Yes, Rahul, we can create archive somewhere else also. So I'll try to show you practical in the future classes. Yes, Nikhil, you can integrate Jenkins with Hadoop. Almost any of the tools and technology, related technology, you can integrate. And that is the reason, guys, Jenkins is known as integration tool also. How to send mail? Maybe in my upcoming class, guys, show you how to send the mail. How to create Maven Docker image? Actually, guys, how to install Maven, you know. How to install JDK, you know. That's all. See, apply same concept in Dockerfile. So those who know Dockerfile, just put those command in Dockerfile, and that's all. Your image create. So nothing special here. But if you don't know how to create Docker image or Docker file, then just go through my lectures of Docker. They explain you from very basics how to create Docker images. How OpenShift better than Jenkins, guys, is not better way to means there's no comparison. Both tool has a different thing to do, right? So most of the time we integrate OpenShift with Jenkins. Okay, so it's not like this. You have to use OpenShift or you have to use Jenkins. Both will do different things. Okay. So OpenShift is like for example content management. So anything Jenkins, any requirement come up that need a containers. Here by chance I use directly Docker. Again, it's not a good way. We can ask Jenkins just contact to OpenShift. In OpenShift on the fly they launch a pod, and on the pod they run the job, and that's all. And for the management part of OpenShift of the pod they will do. So something like this normally we integrate. What if I know my hardware config beforehand? Actually, Rohit, if you know your hardware configuration, right, those configuration you can create one playbook like Ansible. Okay, and after you dynamically provisioning your instance, ask Ansible or Puppet kind of tool. They will first configure your setup on the fly, and then whatever you want to do on there, you can do it. There is again one more approach, Rohit, normally we use. But yeah, maybe sometime you have a requirement that I need my static system to always run. Then you can go for static. But if you think no, every time my configuration of the hardware change or my configuration of OS change, okay. So hardware configuration we can ask Docker, they can provide that much resources to you. Software configuration we can ask for configuration management tool like Jenkins, they will on the fly configure for you, and then your your container launch. Today is my birthday. Tejaswati, from my side, a lot of blessing. Happy birthday from my side. Enjoy your day. So second week I have exam of 294. Yes, Rahul, all the best from my side. I know you guys will will break in one go. But just focus on the boot camp we have done, guys, about 294. Just practice the boot camp very well. But all the best from my side, Rahul. Okay, Tejas ka birthday bhi hai sir. Tejas also from my side. Happy birthday. Enjoy your day. Enjoy your night. Don't study today. So, guys, that's all. That's all from my side. Maybe some more questions you have in upcoming classes. Why we supposed to upload screenshot of what we learn daily either isn't a bit time consuming. Jivita, I don't know actually what exactly you're asking about screenshot on daily basis. I don't think so. We have asked anybody to upload the screenshot. Maybe I don't know which context you are asking. I suggest Jivita, if you can contact to our team, they might